Okay, so I'm going to go like a cat and try and explain this in under 5 minutes. This is a monocrystalline panel. Polycrystalline looks similar, but they have sort of a crystallised look or a galvanised sort of a look through them. This is amorphous. These are designed to last 20 to 25 years and have the smallest size per wattage output. Polycrystalline is usually about 15% larger per output size. These need higher light levels, and I think polycrystalline might need a similar light levels. These amorphous ones will run quite alright under lower light levels. They are 2 to 3 times the size. They are like about half the price as well, but I can only get a 2-year warranty on them, and a lot of people say you only get about 5 years realistic use out of them. Okay. Now, with a system, you don't just get your panel and just whack it straight on your battery. You need what's called a charge controller. The best ones to go for are maximum power point tracking. You'll see MPPT written on them. Now, what that means is, due to a technicality, they can draw about another 10 to 40% of your power that your panel produces. It magically increases by 10 to 40%. Due to a technicality that goes on inside this, compared to a basic one. Now that's the power of MPPT and why people go for it. Now what you basically will have in these charge controllers is terminals to hook up your positive and negative from your panel and other ones from your battery, and you'll have ones that say load. Ignore this, this is built for night lights only. The amount of power it can get out of it is just pathetic anyway. And when you want to run stuff, you just hook stuff, whether it's lights or inverters, straight to your battery. So realistically, you just hook straight from your charge controller to your battery and everything else straight to your battery. And your PV terminals go back to your solar panel. Now, how do you calculate what you need and what not? Well, quite simply, you get the watts of this, and if it's a 12 volt panel you divide it by 12, if it's a 24 volt panel you divide it by 24, and whatever the amps are, whatever that equals, that'll be your amps for your charge controller. Now that'll actually give you one slightly bigger than what you need, but I'm not going to go into the technicalities of how low you can go, because you get a really bright day or someone shine the headlights on it and she might just go kabang and that'll be the end of it. But that'll give you a bigger one, which is good for hot days because it'll run easier before it shuts out from overheating or anything like that. Now your batteries, you'll see there is actually quite a lot of different kinds. Mainly there's just wet and sealed, and there's also gel, and occasionally you'll see AGM written there as well. Make sure that you don't, there'll be switchable stuff in this, so you can switch this between sealed and wet, and you may need to do a bit of button pressing. You may flick a few dip switches. There may literally be a little thing you to put the screwdriver in and turn it around to whatever you want. But basically, don't sit there saying charge a wet battery to this and have a sealed on. You'll have problems. Also, there's something they call equalised charging, and whatever you do, never equalise charge a gel cell battery. But if you've got a sealed battery, make sure this is switched to sealed. If you've got a wet battery, make sure this is switched to wet. I recommend wet batteries because you do have to top them up with water, but they seem to last a lot longer and can stand a bit more abuse, and to sort of enliven them a bit more you can equalise charge them, which is a whole another story. But yeah, so long as you've got that switched to the right batteries and you've got enough amps, the only other thing to know is that you should get your, whatever watts are your panels are, get the same amount of amp hours, or maybe even 4 times the amp hours in that system, in your battery system, and that'll be that.